All right, let's get into it. Today, we're going to do something that's, really fundamental, but also kind of fun. We are going to completely demystify C strings by building our own toolkit of essential functions right from scratch.
So if you've ever jumped into C from, say, Python or JavaScript, you've definitely felt this. You go looking for a simple string type, and what you get feels, well, a lot more hands-on, right? It's a common stumbling block, but there's a really good reason for it, and once you get it, you've basically mastered C strings.
And this right here is the absolute key. A C string isn't some fancy built-in object. Nope. It's just an array of characters sitting in memory. And the only way anything knows where that string ends is by finding this one special character, the null terminator, 0. Every single thing we're about to build today depends entirely on this one simple role.
Okay, so let's frame this as a fun little project. We're going to assemble a virtual toolkit. Inside, we'll build 5 essential tools that'll let you handle pretty much any basic string task you can think of. And by the end, you're not just going to know what these functions do, you're going to understand exactly how they work under the hood. First step in our toolkit is the most basic tool of all. I mean, you can't really work with anything if you don't know how big it is, right? So let's call this our tape measure. Its only job is to tell us how many characters are in a string, and that's not counting the final null character. And that really is the central puzzle, isn't it? The string itself has no idea how long it is. There's no little length property attached to it. So we have to figure it out ourselves every single time. So how do we do it? Well, we have to go looking for the end. The logic here is just beautiful in its simplicity. You just start a counter at 0. Then you start walking down the character array, one by one. For every character you see that is not the null terminator, you just add 1 to your count. The very second you hit that 00 character, you stop. And that's it. The number on your counter is the length. So here's the bottom line. Without that null character, our little tape measure function would just keep on running. It would go right past the end of our string and start counting random garbage in memory, which is like the classic C bug. That tiny \0 is literally everything. All right, tool number 2 for our kit, the photocopier. A lot of the time, you don't want to mess with your original string, right? You want to work on a duplicate. This tool is going to let us make a perfect, totally separate copy. Now, the trick here is making sure we end up with a valid new string. See, it's not enough to just copy the letters HELLO. We have to copy the entire structure, and that means we got to pay very close attention to that all-important final character. The way this works is actually pretty clever. We go character by character from our source, and we drop it into our destination. And we just keep doing that until the character we've just copied is the null terminator itself. As soon as that /0 is in place in the new string, we know our copy is properly terminated and our work is done.
And listen, this is the one detail that trips up so many people when they're starting out. If you forget to copy that null terminator, your new string isn't a string at all, at least not in C's world. It's just a ticking time bomb, a sequence of characters with no end.
Okay, on to our third tool. And this is where it gets really cool because we can start combining what we've learned. This is our welder. You use it when you've got 2 strings and you want to fuse them together into one long string. So how would we actually do this? We need to stick string B onto the very end of string A. Now, think about it for a sec. This task is actually just a brilliant combination of the 2 tools we've already built. So check this out. First, you use the logic from our tape measure to walk all the way to the end of the first string to find its null terminator. Then, starting right there, you use the logic from our photocopier to copy the entire second string, character by character, right on top of it. And just like that, you see how these simple ideas stack on top of each other. So the big takeaway is that this operation that sounds kind of complex, concatenation, is really just 2 simple steps we already figured out. First, find the end. Second, perform a copy. That is the real power of building a good toolkit. Okay, our first 3 tools were all about changing and building strings. This next one is different. It's about asking questions about them. So let's add a precision scale to our toolkit. Its job is to tell us if 2 strings are exactly the same, or if they're not, which one would come first in a dictionary. Now, this is a bit trickier than it sounds. You can't just check if they have the same length. I mean, apple and apply have the same length, but they're obviously not the same string. To really know, we have to inspect them, character by character. The whole process is kind of like using an old-fashioned balance scale. You take the first character from each string and put them on the scale. Are they the same? Okay, Move on. Take the second character from each. Same. Okay, keep going. You repeat this until you either find a pair that doesn't match or you run out of characters in both strings at the exact same time. And that comparison gives us one of 3 possible outcomes. If you make it all the way to the end and every single character matched perfectly, the strings are identical, so you return 0. If you find a spot where the characters are different, you check which one is smaller. If string A's character comes first alphabetically, you return a negative number. If it's bigger, you return a positive number. And that's what allows you to sort lists of words. And for our 5th and final tool, let's do a classic. This is a programming puzzle that's just really satisfying to solve: reversing a string. It's also a fantastic test of whether you really get how strings are laid out in memory. The really elegant part of this challenge is doing it in place. What that means is we're going to flip the string around by modifying the original directly without wasting any extra memory to build a separate, reversed copy. This is all about being efficient. The solution is just so cool. Imagine you put one finger on the very first letter and another finger on the very last letter. You swap them. Then, you move your first finger one step to the right, your last finger one step to the left, and you swap those. You just keep doing that, working from the outside in, until your 2 fingers meet in the middle. Done. The string is reversed. And there you have it, your very own custom-built C-string toolkit. You've got a tape measure for getting the length, which is string length, a photocopier for making duplicates, string copy, a welder for joining strings, string cat, a scale for comparing them, string compare, and a reverser, which is often called string rev. You now know how they all work. So look, by understanding these 5 simple operations, you've basically unlocked the logic behind almost all text manipulation in C. So the real question I want to leave you with is, now that you have these foundational tools, what other, more powerful tools could you design for your own toolkit?